let's talk about another application of area under a curve. There's a power plant in Ludington, Michigan called a pumped storage hydropower plant, where they have Lake Michigan down here and they have a reservoir a few hundred meters up a hill. And if they need power, they can let water out of the reservoir, and that spins the turbines and puts the water into Lake Michigan, and that generates power for the grid. But when power is cheap, or they have extra power, maybe if solar panels are generating more than the power grid needs, or wind turbines or something, they can bring in power from the grid, spin the turbines backwards, and push the water back uphill and save it for later when electricity is more expensive. And you might think, doesn't this like lose efficiency? Like nothing's 100% efficient. And it's true, this is about 77% efficient the last I heard. But it helps stabilize the grid, and it can even help restart other power plants that themselves need power to start up. So let's talk about the calculus of this. So how would you graph what goes on at that plant day by day or week by week? Sometimes it operates with pumping at night and making electricity during the day. I've heard sometimes that it pumps water up into its upper reservoir on the weekends and then lets it out during the weekdays. So let's take that week by week approach. So you might say, well, I've got time in hours here. From 0 hours to how many hours in a week? 168. I'm sure you knew that. And let's say we start on Saturday and Sunday, and we'll say, what's the inflow to that upper reservoir? Inflow to the upper reservoir in million gallons per hour. So if they're pumping during the weekends, that would be high during the weekends, so we'd have like Saturday and Sunday, and let's say that's 1 million gallons per hour. But then during the weekdays, there's no inflow to the reservoir when they're letting water out of it. It's negative inflow, it's outflow, and let's say that's negative 0.2 million gallons per hour. So for a week like this, how much did the water amount in the upper reservoir change? So why don't you pause the video and think about that. Okay, welcome back from pausing. So can we attack this the same way we did our miles per hour and miles driven problem? Well, we've got kind of two blocks here. So the first block would say 1 million gallons per hour times 48 hours, which we could think of as 48 minus 0, gives you 48 million gallons. How about the second block? It's negative 0.2 million gallons per hour times how many hours? About 168 minus, since that started at the 48 hour, I'll put a 48 there. So that ends up being minus 24 million gallons. So altogether for the week, we'd add those two together and we'd get 24 million gallons positive for the week. So the area under this curve is a total of 24 million gallons, even though some of this area we counted as a negative. So that takes some thinking about. So the net area under the curve is positive 24 million gallons. So now not only is area, we were putting quotes around area before because area isn't measured in gallons, but now we can even think of some areas as negative, which is completely not what we learned in geometry class. So in the calculus, if the function is negative, the area is also negative because we have to go up to the x-axis instead of down to the x-axis. So in calculus, if the function is negative, the area under it is also negative. So this is the third of the three big ways that calculus sometimes uses words differently than maybe high school math. So we can have negative areas, and areas can be measured in gallons or miles, like on the previous example. In the derivative section, we had tangent lines which didn't always have to touch in just one point. In fact, if the tangent line touched the original function at every point, that was great. It was a great linear approximation. To touch at every point, it would have to be originally a linear function. And then in our limits section, we'll talk about asymptotes, which we sometimes think of as something that a function gets closer to but never touches. But in calculus, a function can not only touch its asymptote, it can cross it, it can be exactly equal to it forever. So those are the big three ways that calculus redefines words that we're used to from other math. Let's write those down. I'll pause and write it down. Okay, there we go. I forgot to mention a function can cross or touch a horizontal or slant asymptote. It still can't cross or touch a vertical asymptote by the definition of function. All right, next we'll talk about all this net area under the curve stuff and some new notation.